right, let's go ahead and look at this late model Chevy now with a new mass airflow sensor installed and see how much better it looks. Well, it was a case of the sensor being malfunctioning, skewing, putting out a signal but not an accurate signal, not near as much airflow as in actuality, and that's why we had the high trim numbers trying to compensate for air we didn't know was getting in the engine. So now let's go ahead and clear that code and see if it comes back. All right, read DTCs, they're gone. Now let's go ahead and look at our data. All right, same PID, same order. Let's start it up, watch the meter, and we'll look at the scope too. Little different voltage, but more importantly, digital sensor, a little different frequency. We have 193 hertz and 8 grams per second of air. Let's rev it up as much as you can. 22 grams per second of air, 3,000 RPM. All right. Let's watch that meter again. Now we've got about 2.6 kilohertz, 2,600 times per second. Rev it up again. A little higher, about 4 kilohertz. All right, idle it down. Let's look at that scope now. There's scope. Now rev it up. Idle down. Shut it off. So definitely different PID numbers, higher numbers, more airflow. Hard to tell with the scope unless you're doing the frequency calculation. You're looking at your x-axis, left to right, time, and you're doing the calculation of how many hertz it is. Most guys that use a scope, you're just looking to see if you're getting a signal, and it'll look like a good, crisp, clear signal. So the bottom line is we look at the difference between the mass airflow readings and what trim's doing, rev the engine up, see if we're getting enough mass airflow readings. It's always good if you have a scope to look at known good readings. Also, known good scan tool captures on how many grams per second you should see. A lot of techs will know this.